So guys, now let us try to understand the difference between asynchronous and multi-threading programming. So if you browse the internet and if you just do a Google search that what is the difference between asynchronous and multi-threading programming, you will come across many articles. So it is a very common confusion that whether asynchronous programming is same as multi-threading programming, and if not, then in what respect are they different? So to begin with, the asynchronous and multi-threading programming appear to be same, but they are actually not. Multi-threading is one form of asynchronous programming. So you can see in the diagram on the right hand side, asynchronous programming is actually a bigger world. And multi-threading programming is just one of the part of asynchronous programming. Alright, so the moment you write a multi-threaded program, it is true that you are also writing asynchronous program. But what surprise here is that a single threaded program can also be a asynchronous program. And this is what we will going to do in this course. We will going to write a single threaded asynchronous program. So asynchronous programming can be done with a single thread as well as with multiple thread. There is no limitation in this regard. Multi-threading is all about launching worker threads who are assigned some work to perform in parallel. Alright, so I hope you understand what exactly multi-threading is. In multi-threading, you have some threads which are called worker threads. They are assigned a chunk of work to perform in parallel. Whereas in asynchronous programming, it is all about task. Task means a chunk or piece of work to do. Alright. An application at any given point of time can have a set of network packets in a queue to be processed. So for example, you have some application and that application has received some network packets on the socket. And those network packets has been queued up into a queue, but those network packets has not been processed by the application yet. So in a way, the application has a task to perform. And that task is nothing but processing these 10 network packets which has been queued up into a queue. Similarly, an application can have a pending task to process timer callback function. A timer callback is nothing but it is a function which is invoked by a timer. Alright? So an application can have one more pending task to perform. Then an application can have another task in which an application itself has manufactured a network packet and the application has to send this network packet to some remote machine. So in a way, the application has one pending work to do. And finally, it might be possible that as an end user, you have triggered some CLI or you are trying to interact with the application using GUI, and the application has been submitted a request from the user to process. So this is the task number 4. So you can see that at any given point of time, an application can be bombarded with number of tasks to perform. So now the question arises that how would application going to finish these pending tasks? Alright, and in what order? And would the application going to execute this task in parallel by launching parallel threads, or the application would going to perform this task sequentially? And while executing the current task, more tasks may come and queue in. Alright. So welcome to the world of asynchronous programming, where we develop programs which divides a piece of work into individual independent tasks and then execute those tasks in some particular order. So we will going to develop a library, a mini library in this course, using which your application can execute its internal logic by dividing the logic into independent tasks and then executing each task independently. So now going forward, so what is a synchronous single-threaded application? As the name suggests, it's a single-threaded. It means the application has one thread and it is synchronous, meaning that a task T1 is performed and the next task is triggered only when the previous task is completely executed. So you can see that this represents a synchronous single-threaded model of application. Each task is performed only when the previous task is completely finished. And there is a single thread which is executing the task one after the another. Alright. Then come to the second model, which is called synchronous multi-threaded model. If you design your application by using this model, you would see that your application would have to launch multiple threads. Alright. And each thread is associated with exactly one task to perform. So thread 3 is executing task number 3, thread 4 is executing task number 4 in parallel. So it is synchronous because each thread is associated with exactly one task, and it is multi-threaded because your application has launched multiple threads to execute multiple tasks in parallel. Then coming to the third design, asynchronous single-threaded. Since it is single-threaded, it means your application would be a single-threaded program, but it would execute a number of tasks in an asynchronous way. For example, it has partially executed task T1 and then switches to execute task T2. And then after partially executing the task T2, it again switches to the task T1 to finish the remaining work associated with task T1. And once the task T1 finishes, then it may switch to perform task T4, then it may switch to perform task T2 again, and it goes on. So you can see that the order of executing tasks in this model of application design is not definite. The fact that tasks can be executed in an arbitrary order leads to the asynchronous design of an application. You can see that the task T1 can be executed partially and the remaining portion of the same task is executed sometime later. Alright. So you can see that no task consumes the CPU for a very longer time, because in asynchronous single-threaded application, an application may choose to preempt the task while the task is still not finished and then load another task to compute. And then finally comes asynchronous multi-threaded application design model. In asynchronous multi-threaded, not only an application launch multiple threads, but each thread also execute a set of tasks in an asynchronous manner. Alright. So in this course, we will going to design a small library which allows us to implement application using asynchronous single-threaded design, and then we can extend this design easily to implement an application using asynchronous multi-threaded design. I will show you how a single-threaded program using asynchronous programming can compute the sum of all the integers in an array as well as multiplication of all integers of an array by dividing these two pieces of work into tasks.